Use the labels they have for setup. I believe part A is going to be about 2 to 3 points. And anyways, the tide removes with the R of t function. The tide, and this would happen. They would probably do this during high tide and low tide, and from 0 to 6. I imagine they probably do this when nobody's on the beach. So from 0 to 6, maybe it's from midnight to 6 a.m. Okay, maybe during the day they don't pump sand back on the beach. Maybe this is during the night. I don't know. We don't have any more information about this problem. I'm just guessing. But they only do it during a 6-hour period, and then the other 18 hours of the day, it's off. They just let it erode away. Okay. So how much sand will the tide remove from the beach during the 6-hour period? How do you set up part A? Yeah, definite integral from what? 0 to 6. R of t dt. I don't know if that's 2 or 1 point, but it's definitely 1 point. And you do not need to write the equation. Why?
Yeah, you're kind of good.
Because they gave you a label. What I do not want you to do here, we are going to use the calculator. What I do not want you to do here is put y1. Absolutely not. Do they know what you put in y1?
No.
No, you need to use the label that they understand. So 0 to 6 of R of t dt. Can somebody tell me what you got for the answer? 31.816. What's the units?
Cubic yards.
Cubic yards per what? Per what? Per hour. So it removes from 0 to 6. It removed. Wait a second.
Yeah, that's not right.
It's
That's a number. That's a quantity.
It's cubic yards. And here's why. R of t is measured in what, guys? Cubic yards per what? Hour. What's dt measured in? Hours. The hours cancel and you're left with cubic yards. Okay? So 31.816 cubic yards. And that removed sand from the beach. Okay? It removed sand from the beach. Part B. Write an expression. This almost reminds me exactly of that amusement park problem when we had people enter the park and leave in the park. Write an equation. Y of t. Now, did they say find? Did they say you need to simplify anything? They just said write a what? An expression. Something that will express it. Doesn't mean you have to simplify it. Doesn't mean you have to figure it out. Just means here's an expression that would calculate the area, the total amount of sand in cubic yards on the beach at time t. Now remember, these are rates. So anytime you integrate a rate, you're always going to end up with a displacement, a quantity. Okay? So y of t, ready? What do we have to take into account if we want to know the total amount of sand on the beach? You got to know at any time t. What else?
Time t0 it starts with.
You need to know the start. You need to know how much sand you start with. They always want at midnight to be how much sand on the beach? Yeah, 2,500. So we're saying start 2,500 plus displacement. Now here's the deal with displacement. There's 2 things to take into account during the day. How much sand is being added and how much is being removed. Which one is going to be subtraction? R of t, the one that's removed. That's the one that's taking sand away. So we're going to have the integral. Ready? Now this is at any time t. So we're not going to go from 0 to 6. We're going to go from 0 to what? T. All right? And we're going to do the one that adds to the beach first. Which one adds? S of t minus what? R of t dt. That's worth 3 points. Right there, done. 3 points. Let me tell you where you got your points. You'd get 1 point for the 2,500 for knowing how to use the initial condition. You'd get 1 point for the 0 to t. And you'd get 1 point for the integrand S of t minus R of t dt. Now, let me go ahead and clarify something, because some of you are probably already looking at it and saying, we've got a t here and we've got a t here. I don't know which t's for which. What are we supposed to do?
Make them different signs.
We should actually make this what?
X or something.
S of x minus R of x dx. Now, let me go ahead and tell you on the AP exam, a lot of times they won't take that point away if you forget. But let me tell you right now, it will be confusing to you, because when you actually do fundamental theorem of calculus here in a second, part 1, you're going to be like, which t am I integrating? Well, the one at the upper limit of integration. So you should switch them, even though they'll probably be lenient there. Okay? They do write it right, but from what I've read, I think they're pretty lenient there. But let's just do it the correct way. All right, part C. How many of you would have gotten the first two parts? How many of you actually thought of that or could have thought of that on your own? Okay? Pretty close, some of you. So start value plus the integral displacement. This is how much is adding to the beach. This is how much is taking away, which is why you subtract RFT. Now, you're getting part B. Part C is either dependent upon you understanding this or being really intuitive. Okay? Because they want you to find the rate at which the total amount of sand on the beach is changing at 4. So in other words, they want you to find y prime of what? 4. They want you to find y prime of 4. Now to do y prime of 4, you got to find what first? You need y prime of t. What's the derivative of a constant? 0. Now we get to this. This is FTC part what? This is FTC part 1. How do you take the derivative of an integral? You just plug in the upper limit of integration. So what is this going to change to? S of t minus r of t. Now here's the dealio. You're going to love this. You could get there without understanding part B. Let me explain. This is so intuitive. You don't even have to understand part B to get this derivative. Because if you want to know the rate of change at which the total amount of sand is on the beach, aren't these already the rates? So doesn't it make sense that it's the rate at which sand adds to the beach minus the rate at which sand removes from the beach? Couldn't you get there without understanding part B? Part B just confirms it. Part B just confirms, yeah, the derivative of this should be that. So if the derivative of this is that, you know you did part B right. Or you just created something that worked. Yeah,
Can you explain again why S is first?
because it's adding. It's the positive one.
Okay.
We want the one that's negative to be the one that's subtracted, taking away.
What if they're both?
They won't. Okay? Otherwise you'd add both. Alright, so we got this. So we just want y prime of 4. Somebody tell me how I can use my calculator so I don't have to show a bit of this work. Go to your home screen and go, where did you put the S function? Y1 or Y2? Y2. So go Y2 of 4 from the home screen minus Y1 of 4. No, you better not use Y's.
What if you write at the top of the equation?
Don't do it. They don't like calculator notation at all.
Even if you say it's equal to RT?
I specifically in their directions they say not use calculator notation. Alright, what's S of 4 minus Y of R of 4? Negative 1 point? Huh?
Negative 1.909.
What's the units here?
Cubic yards per hour.
Cubic yards per hour. This is a rate, so this should be cubic yards per hour. So are we gaining or losing? At 4 hours, have we caught up?
No.
The pumping station still hasn't caught up. We're still losing more than we're gaining. Okay? Now they're probably always going to keep it a little bit more to the losing side because you don't want to add too much sand to the beach. But at 4 hours, at that moment, we're losing more sand than we're gaining. Okay? Part D, from 0 to 6. This is an awesome problem. From 0 to 6, because we got everything we need, by the way. From 0 to 6, at what time t is the amount of sand on the beach a minimum? What is the minimum value? Justify your answers. By the way, part C was probably only 1 or 2 points. You probably got 1 point for knowing y prime of t was s of t minus r of t, and then you probably got 1 point for the answer. So we got 2, 3, that's 5, 6, 7. This last problem is probably 2 points. 2 or 3. I'm just guessing right now. All right, how do you do a problem where they want you to find the minimum value?
Find the critical values.
And check endpoints and critical values. So we're going to have to check. And we're going to have to check it in the original function that tells me total sand on the beach. So guys, here's the thing. If you don't understand part B, you will not get part D. If you don't understand part B, it will be impossible to get part D. You got to at least have an understanding of it. You might not have the equation right, but you got to understand that it's going to be start plus displacement. If you don't understand start plus displacement, I don't know how you're going to get y of the critical value, whatever the critical value ends up being. We're going to use the calculator here because this is the hard part. I think this is the hardest part because some of you are not going to know how to use your calculator to get the critical value because you don't know how to do a zero still. Okay, now, by the way, here's your justification. First thing, you will get a point for part D, I guarantee it. they don't need you to find the endpoints because they told you the endpoints. So you saying an endpoint 0 and 6 is not getting you points. Checking it will get you points. But the first point you're going to get, I guarantee every time on this one, whenever you use extreme value theorem, you're going to get a point for finding the critical value. How do I find the critical value for y of t? If you write y prime of t equal to 0, you will get a point. I guarantee it. It was the same point last week on the answer key, and it's the same point the week before. Traffic flow, when you look at it today, already looked at the answer key, you get a point for setting the derivative equal to 0. Now some of you are like, what if I don't put y prime of t? What if I put s of t minus r of t equals 0? Same thing, you'd still get the point. Either one, you don't have to do both. Now you're going to use your calculator to do it. How can I use my calculator to get this? You're definitely going to want to go to a y what?
Y1.
You already got y1, y2, but I don't have s of t minus r of t. Where can I put that in? y3. You're going to want to go to y3. Now, you got to make sure you get it in the right order. I want s of t minus r of t. So what's going to go in y3? y2 minus y1. Now here's what I would do. Ready? I would turn off y1 and y2. Turn it off. How do you turn off y1 and y2? Unhighlight the equal sign. You need me to bring my calculator up? Can you do this? Okay. Unhighlight the equal sign. Now, we only care about looking from what to what? 0 to 6. So if you haven't reset your window in a while, I'd hit zoom 6 first. But if you have reset your window, you can go ahead and change your X-min and X-max. So you can zoom 6 it. You might not see everything the way you want it to see it. So if you zoom 6 it, you'll see a standard window.
That's cool.
Then we can go through and change the standard window. How do we change it? We want to change the X-min to what? Go to window. Everybody press window. Press window. What are we going to change the X-min to? You guys tell me. 0. What are we going to change the X-max to? 6. That's all you need to see. Now press graph. Now what are we looking for? Where it crosses the what? X-axis.
Right there.
Now you can't guess. You can't be like, oh, I don't know. I don't. Now look. Here's what I got with Chris's. Everybody kind of look, visualize. It looks like, here's the thing. Over here at the left, are you absolutely certain it doesn't cross the x-axis?
Yeah.
How can you be certain?
It doesn't cross it.
You can zoom in that area if you want.
Yeah, but it would it, well, it would still be
It goes from negative to positive.
but if it doesn't go, if it hits the x-axis and stays back down to negative, does that just mean it's not a point of inflection?
Yeah, so here's the deal. On the left one, even if it does cross, Peyton made a good deduction here. Good job, Sherlock. It went below, even if it hits that x-axis, is that going to be a possible minimum? Below to below, negative to negative, does that make a max or a min? Now, over here, where it goes below, above, this is the derivative we're looking at, isn't it? So it goes from below to above, is that a possible minimum? Yeah, so we don't even need, what we need to do is figure out what that is. How do you figure out what that is? Second trace, do your left bound, right bound guess. Can anybody tell me what that is?
5.12.
5.1?
5.11.
5 point what?
1.8.
5.118 hours. Now, let's stop here. You ready? Here we go, 5.118. You just got another point. So you got 2 points. The third point is going to be from your justification and your answer. Now here's how you justify and get your answer. You ready? So we're going to go y of 0. Can somebody tell me what y of 0 is? That was given in the original equation, 2,500. Maybe that's the minimum. I don't know. I doubt it. Now we're going to have to go y of 5.118 and y of 6. And this will, when you get those two answers, you will get your justification. So now we go back to part B, and we're going to go from the home screen. Home screen. You ready? Home screen it up. We're going to go start plus displacement. Ready? Somebody tell me what we're going to do for y of 5.118. You're going to go to the home screen. Erase that right there. And here's what you're literally going to do. You're going to go 2,500, where you started from, plus the definite integral from what? 0 to 5.118 of what? Come on, help me. Of what? S of x minus r of x dx. Where is, I believe you have S of x minus r of x in your calculator. Y3, it's going to be your Y3. Give me an answer. Just give me an answer.
2,492.3.
That's right. 2,492 point what?
369.
369. And that's cubic yards. All right, now, how do you do the next one? Tell me how to do the next one. Come on. 2,500 plus the integral from 0 to 6 of S of x minus r of x. By the way, you could have just hit, by the way, listen, you could have just hit second enter. It would have recalled your typing, and you could have changed the 5.118 to what? 6 to save yourself some time. What do you get for that one, Lizzie?
I don't my calculators.
2,493.
Ooh, look how close it was. 2,493 point what?
277.
Look how close it was. They were really close. Which one's the min then? The min is the 5.118, which is, and they wanted to know the min and the min value. So they wanted to know at 5.118 is when you achieve your minimum, and the min value is 2,400. You're going to have, and what does that min value mean?
It's the lowest.
That's the lowest the sand. Because of erosion, they're always going to keep it a little bit under, but they're not going to keep it very far under from that. And it's going to be, there's an amount of air here, so it's going to be plus or minus, so they're going to keep it close. So it almost gets back up to what originally was on the beach. Okay, any questions? Let's do one. You want to do one more? I'm up for one more. Yeah, let's do one more. All right. Let's try. Oh yeah, this is a good one. Let's try number 3. Try number 3. And we'll call it good after this. This has got some Riemann